In this video, I'll be talking about how to take a forces situation and turn it into a system schema diagram and then translate that into a free body diagram. So we have a picture here. We've got a couple of blocks that are moving along a table and being pulled by a series of strings. So a few big pieces of information is we know that we have some sort of an applied force pulling in this direction on string 1 connected to block A. And block A and block B are connected by the string in between those two. And one important piece of information more when we get to the free body diagrams is that we are at a constant velocity. So that will change how we draw some of the forces. But first, let's jump to the system schema diagram. So our first step is we want to write down all of the objects that we think are interacting in the system. So two of the easiest ones are going to be block A and block B. So I'm going to write that as B and make a little circle around it. I'm going to say block A. We got some interactions with string 2. So I'm going to write S2 to represent that. I'm going to write S1 here. We also have some sort of an applied force. So I'm going to make an assumption that we have probably somebody's hand that's applying that force, or maybe a person. We have the floor that the two blocks are in contact with. And one really important thing that we need is also the earth, because that's where our primary interaction of gravity is going to be. So now that we've listed all of the objects in our system, we want to write down all of the interactions that are happening. And so to do that is we just need to make some double arrow connections between those. So if I look at block B and string 2, it looks like there is some sort of a tension force between those two objects. So since we have that string, so I'm going to say force of tension between those two. Notice how block B and block A do not touch each other. So besides a little tiny bit of gravity, they don't have any force interactions between them. But if we're sticking with block B, it looks like we have the force of gravity between the earth and block 2. So I'm going to draw our double arrows there. We also have, it looks like a friction interaction between the floor and block B. We also have a normal force. So since those are in contact, the floor is pushing up on block B. The hand is not directly affecting block B. Like we said, A is not directly affecting block B, and it looks like string 1 isn't either. So that kind of limits our focus to some of these other objects. So if we do the same thing for block A, it looks like we have a tension force between block A and string 2. This is where it's going to get kind of messy. Tension force between A and string 2. We also have a tension force between A and string 1. So I'm going to write that down as well. We have a friction force between the floor and block A. We have a normal force between the floor and block A. And then we have the force of gravity between the earth and block A. Now notice I am still not having any interactions with the hand because it's not directly affecting any of the objects that we've put on there before. So maybe let's take some time to work out the hand. So the hand, it looks like there's some sort of an applied force between that and string 1. So I'm going to write FA and connect our hand to string 1. And then there's probably a gravitational force between the earth and the hand as well. Okay. That's a lot of different forces going on. If we want to, we can also add there's probably a gravitational force between the earth and the floor. Pretty much between the earth and any objects, there's going to be that gravitational attraction. So that is our system schema diagram with all of the major forces that are acting on it. Our next step is to change that into free body diagrams. And what I want to do is focus on block B and block A. So I'm going to make a little line here so we can focus on those interactions. So I'm going to say this is my object block B, and this is my object block A. And we'll try to find some forces acting in those directions. Okay. So when I focus on block B, I'm going to take the hard work that I did with the system schema diagram, and I'm going to put a circle around all those forces that have to do with block B. So in my free body diagram, I know that I have to have the friction force, the normal force, the tension force, and the force of gravity, because those are all of the forces that are kind of breaking into our focus system. So let's start with the force of friction from the floor. And I probably should have thought of this in advance. I'm going to scooch this down here. So we have the friction between the floor. Since we know we have a constant velocity going to the right, that means that we must have a normal force that is going opposite but parallel to the motion. So it's going to look funky. I'm going through that B, so I'm going to write F sub F, which means our force of friction. Let me scooch the paper over just a little bit. Force of friction on block B by the floor. So notice we have that on and that by notation. Next thing I'm going to do is that normal force. So let's have that going up here. Label that Fn, and that is on block B by the floor as well. So we have two interactions between the floor and block B. Let's check out that tension force. So that tension force looks like it's pulling block B in that direction. So I'm going to write Ft on block B by string 2. And last but not least, we have those three forces knocked out. Let's do that gravitational force. So I'm going to write Fg, and according to our system schema diagram, it is acting on block B by the Earth. And it looks like those are all of the forces that are interacting with block B. So now let's jump to block A. I'm going to do the same idea. I'm going to take all of those forces that we know are interacting with block A. I'm just going to kind of circle those so I can focus my system there. And let's kind of do the same thing. So we've got force of friction between the floor and A. And since we are moving to the right, friction must be pulling back on us. So I'm going to write F sub F on A by the floor. We've got normal force between the floor, and that's perpendicular to our surface. So I'm going to say Fn on block A by the floor, similar to what we did earlier. Okay, so I knocked these two out. Let's do gravity. So we've got a gravitational pull pulling downwards. So we've got Fg on A by the Earth. And now we have these two tension forces. So we need to figure out which direction those are going to be moving. Let me scoot this over just a little bit so you can see what the heck I'm doing. So we have our friction, we have our normal, we have our gravity. Now we want to do the same thing with our tension forces. So string 2, according to block A, is kind of being pulled back by block B. So string 2, we're going to write in that direction because it's kind of pulling our object back. So I'm going to say force of tension on A by string 2. And kind of in a similar way, it looks like our hand or our person, whatever's pulling that, is pulling string 1 in that direction, which is going to make the tension force going to the right on A by string 1. All right, now let me zoom out real quick just so we can see everything in one fell swoop. So one piece of information we need before we finish off our free body diagrams is the fact that our objects are moving with a constant velocity. So if we have a balanced force diagram, we know that our objects are moving with a constant velocity. We're kind of working backwards to show that as well. So if I look at this free body diagram, that must mean that in this case, the normal is equal to the gravitational force in the y direction. We must be balanced in the x direction. And the same thing with our forces over here. So now notice that there are 3 forces in the x direction. So while I don't want to put congruency lines on there, we do know that these forces pulling to the left are equal to those pulling on the right. But we can write the normal force and the gravitational force are going to be equal to each other.